Today we're going to talk about variables as well as user input and how we can use those in our Pico programs. All right, hopefully you have already looked at the lesson on digital output. We're going to use that as a starting point for today's discussion. If you haven't, it might be useful to go back, but I will do a quick review. All right, let's take a look at our setup so far. And here is our Pico sitting in a board, and the circuit is just an LED hooked to a pin. So I'm actually going to draw the circuit, and this is what it would look like. First of all, I'm saying it is attached to pin 9. There is a resistor. It is 330 ohms. And then the next thing in the circuit is your LED. And then finally, a ground. Now let's look at this here, and you might notice, hey, this doesn't look like that's a 9. It looks like 12. Well, remember, this is one thing that is very tricky about using the Picos, is the numbers of the pins are not obvious from looking at the top. Actually, if you had one that was not in a board and you flipped it over, you would see that the numbering is actually available on the underside. And that's not super convenient when you have it in a board. So hopefully you have seen already in other videos that I actually created this little chart for you. And the idea behind this is a lot of information here. But these are the pins. So if we take a look at, for example, this first pin would be this one, and so on and so on. So if we want pin 9, this 12 indicates that the number on the breadboard for the Pico pin 9 is 12. So make sure that you follow that. This is a source of a lot of confusion, unfortunately. Okay, so first of all, from the 9 volt to the 330 ohm resistor, this blue lead goes from there. This is pin 9, but breadboard slot 12. And then you will see that connected to the blue lead through the resistor. And how do you know it's a 330 ohm resistor? Well, you can look up the color coding, or you can just make sure that it is in some other way. It's going to be orange, orange, brown. All right, and then that connects to the correct side of the LED, and then that goes back to a ground. And remember, from your graph here, from your pins system, I'm actually using this one on the right-hand side of the Pico, but you could use any of these. All right, so hopefully you remember that. Now let's go back and take a look at the code that we use to make all this work. All right, now, as I mentioned before, when you have a Pico program, and this is using MicroPython, remember, I think of it as consisting of 3 different parts. Okay, so the first part is the imports. This brings in libraries, software libraries that we're going to need in order to achieve our results. The first one is the one that's needed so that we can configure the pins on our Pico. The second imports the sleep function, which allows us to delay, to actually pause between different commands. The next big thing here, the next category of things in a Pico program, is configuring the pins. We're telling the microcontroller how we want to use each of the pins, because these pins are flexible. So pin 9 is what we call a general purpose pin, and it can be configured in different ways. When we have this command right here, we're saying, hey, we want to use pin 9 to make an output signal. And this is going to be a digital output signal, so logically either high or low. We know that high is 3.3 volts, low would be 0 volts, or effectively ground. Now, So we've configured our pins here, and we've given the name of the pin 9 LED. Then comes the while true loop. And remember that when you have a while true loop in Python, it will execute the commands that are indented below it forever, or until the system is powered off. All right, so LED on turns it on, makes the pin go high, so the LED goes on. We sleep, in this case, 0.5, and that's seconds. And then we turn it off, then we sleep again for 0.5 seconds, and so on. So what we see is the blinking that you saw in the previous view. All right, there is nothing wrong with this program. This is called the classic blink sketch that shows you how to use digital outputs. But oftentimes it's inconvenient when you're using values like 0.5 directly like this. It is oftentimes better, well, the reason is because if we ever wanted to change this, we'd have to go and change these values everywhere they appear. So another strategy is to use a variable. Every programming language uses the idea of variables. A variable is name storage in memory for information that you're going to use later in your program. So if I wanted to create a variable in this case, the first thing that I need to be aware of is that there's actually different types of variables. If I go back to here, I'm just going to give these some of the types of variables. Types of variables. All right, there's many types of variables, but there are a few common ones. The first one is an integer, and that's things like numbers like 3, 5, -1, and 0. And notice that I have no decimal points. The second very commonly used type is a float, and it is also a type of number, but it's always associated with a number that has a decimal point. So 3.3 -100.0, and so on. The next thing is a Boolean value. All right, so a Boolean value just has two values. It is true and false. And you might recognize the true for when we created our while true loop that goes on forever. One more thing that is useful is the string. So a string is really just a sequence of character if we wanted to communicate something, and we could do it this way. So this is an example of a string. You can tell by the quotes. Python allows you to use either double quotes or a single quotes. But if you start with a double, you must end with a double, etc. All right, let me just show you, if I go back to my Thani here, I'm actually going to use my shell here. And if I go in here, you'll see that I can create a variable in a very straightforward way. So, for example, if I wanted to do I think I need to stop this. All right, so if I want to just create a variable, I'm just going to give my variable name I is equal to 7. And if I do that, I can actually ask Python, hey, what type is that? If I do type I, then you'll see it says int, which means integer. X is equal to 3.3. You might guess that that is going to be a float. Let's see what it says. Type X is float. I can do a Boolean. I can do, oftentimes a Boolean value indicates something that's happening on your Pico. So I'm going to do is blinking. Notice that the way that I name all these variables, all lowercase, if I have more than one word in my variable, the convention is to have an underscore to connect the words. Python doesn't really care, but that's just the way that the Python programmers have elected to do it over the years. So if I did this, and then I did type is blinking, and it will give me bool, which stands for Boolean. Finally, if I did something like this, greeting is equal to hello, then type greeting like that. Now, some languages that you have encountered, perhaps, you actually have to specify the type of the variable when you're creating it. Python does not require that. As a matter of fact, it doesn't really allow it. So Python determines the type of a variable based on the value that is assigned to it. All right, now let's go back to our blink sketch here. And let's see, how can we actually change this, or I would say improve it, using variables? So one idea would be, instead of having these hard-coded literal values in my code that are repeated, I could create a variable and give it that value like so. So in here, I can now replace a value with a variable. One key idea about variables is that whenever you can use a literal value, like 0.5, you can replace it with a variable. So if I were to change this, and I'm going to run this, and let's go back and show this. And you'll see it's still blinking as before. In general, it is considered good practice to, instead of having many different hard-coded numbers in your code, you should actually use variables. The other benefit of it is it becomes obvious to someone reading your program what the purpose of this number is. Delay, now we kind of, the variable's name indicates what it's going to be used for. So try to get in the habit of, instead of having sprinkling your code with all kinds of different numbers, use variables to identify which each thing is. Okay, now we could also do, for example, up here, we could actually change the pin number. So for example, let me just put all my variables together just to kind of clean things up a little bit. Delay, I could actually do LED pin is equal to, and then I could do 9, and now I can do LED like this. And it will actually, well, when it does that, that means that I've tried to run it. When it's already running, you need to stop it and then run it again, and the behavior will be unchanged. All right, now one thing that may not be obvious to you, but I want to bring it up right now, is we actually have already been using variables. Right in here, you'll see this LED. That also is a variable itself. So I mentioned that there are types of variables were the ints, the floats, booleans, and the strings. LED is also a variable, and it refers to, its type is none of those. Its type is a pin. So when you see a statement that looks like this, I'm on the right-hand side, you see this capital pin and then parentheses. This may mean that I am creating a thing called a pin, which is made available to us through the MicroPython code, and I'm saving that in the variable LED. So LED now refers to that pin, and MicroPython knows all the things that a pin can do, and that's what makes it possible for us to use these commands. Okay, now before I leave this topic, I wanted to give another example of using variables. Sometimes when you're running code, you actually want to get information from the user to help you control the program. For Picos, this would only be relevant when you are physically connected. The Pico itself is physically connected to your laptop or your computer via the USB cable. If you're not connected, then you will not be able to use this mechanism to get information from the user. So just be aware of that. All right, so here is the idea. Instead of having a delay be hard-coded, we are going to ask the user for that value. Okay, so I've boosted the size of the font a bit just to make it a little easier to see. So in user input, there is a method in Python that is called, well, input. So let me show you how that works. I'm going to go down to the shell and show you this. If I do X, let me actually hit stop and run again. If I do let me go back here. If I do I is equal to, and then I use input a number. And I can format it any way I want. So notice that is echoing back the string that I put inside here. So that's the first part of how this works. But notice it is now waiting for me to enter something. So if I input a number 56 and do return, then what it does is it captures the value I've put in and it assigns it to this variable. So if I were to do print I, then you'll notice it is indeed 56. Now, this is a great way to get information into our system. This applies to MicroPython when your Pico is connected to your computer with USB, but this is a general Python feature as well. Now, one thing to be aware of, if I do this, type I, well, that's a string, even though it looks like a number. So we need to be careful, because if we want to use a number, let's say it's either an integer or a float, I need to explicitly tell that to Python. So if I wanted a number to be a float, I could do this. X is equal to float, and then I, and then if I give X, it is 56.0. Notice the decimal. If I do type X, then it is converted to a float. So sometimes it is necessary to convert from one type to the other. Now, let's go ahead and instead of using a delay, that is a variable that we set at the beginning of our program, we're going to make this, we're going to actually ask the user for the delay using the input method. Now, if I did this, input the delay in seconds, then the problem is it would return this as a string and it's not going to work. Oops, I accidentally use open quotes to begin, therefore I need close quotes to end. So in order to convert this into a float, I do this. I use the keyword float. I surround the entire thing like this. All right. Now, let me go ahead and run this and I will show you how it works. The first time, let's do something much smaller. I'm going to do 0.1. If its delay is only 0.1, it should run very, very fast. And let me go and show you what's happening. So you'll see it's actually typing, it's actually flashing very, very fast. All right, so in summary, variables are useful in programming in many, many different ways. One way that we can use it in our programs is to identify those numbers that otherwise would be sprinkled through our code. And identify them, give them a name that makes sense so that other people can understand what we're doing, including us. Sometimes we can get very confused about what our own program is doing unless we try to name things well and structure our programs well. The second thing that we learned is the use of the input if you want to input information that the program can use.